Hi everyone, this is Mythri. Welcome back to my YouTube channel. Now I am here to explain a small topic about computer organization and architecture. Introduction to computer organization and architecture. Computer organization refers to the physical components of the computer system such as CPU, memory, and input and output devices. Computer architecture refers to the design and the structure of a computer system, including the instruction set architecture and a memory hierarchy. Understanding the computer organization and architecture is a crucial for effective and efficient computer system design. CPU, Central Processing Unit. The CPU is the brain of the computer, responsible for executing instructions and performing the calculations. It consists of control unit, which manages the execution of instructions, and arithmetic logic unit ALU, which performs the arithmetic and logic operations. The CPU interacts with other components of computer systems such as memory, and input and output devices to process the data. As shown in the figure, it is a block diagram of CPU. First thing, what we enter the information as an input, it sends to the control unit. The control unit controls the program, control and process the information and sends to the processor. Processor sends to register, register sends to the combinational logic, and what we get result it will send to the output, it will get as result what we get the output it will consider as a result. If you want to save the information means it will send to the main memory. If you don't want means again the process will be run as it is same. Main memory hierarchy. The memory hierarchy refers to the different levels of memory in a computer system, from register and cache to main memory and secondary storage. Registers are the fastest but smallest form of memory located directly in CPU. Cache memory is the smallest and faster memory that stores frequently accessed data and instructions, reducing the access time to main memory. Computer memory hierarchy. First thing, volatile near instantaneous use, volatile immediate term use, volatile very short term use, non volatile short to long term use, non volatile long term use, volatile very long term use. Instruction set architecture. The ISC is the interface between the software and hardware of the computer system. It defines the instructions that a computer can execute and the format that instructions. Different computer architectures, example x86, AMR, have different instruction set of architectures which can affect the performance and compatibility. It's a layer of abstraction diagram. First one, application, algorithm, programming language, assembly language, machine language. What we discuss now, instruction set of architecture, microarchitecture, gate, a register, device, transistor, and physics. Last thing, parallel processing and pipelining. Parallel processing involves the performing the multiple tasks simultaneously by dividing them into smaller subtasks that can be executed in parallel. Pipelining is a technique that allows the multiple instructions to execute co- concurrently, overlapping their execution stage to improve the performance. Both parallel processing and pipelining can greatly enhance the speed and efficiency of the computer. Sequential and parallel processing. First thing, sends program task one sends to CPU and we will get the result. Input output devices. Input output devices are used to interact with computer systems such as keyboard, monitor, and printer. They provide the input computer or display output from the computer. The CPU communicate with input-output devices to the a controller, which handles the data transfer between the device and the computer system. Example of, as shown in the figure, examples of manual input devices: keyboard, numeric keypad, pointing device, remote control, joystick, touchscreen, scanner, graphic table, microphone, digital camera, web camera, light pen. Von Neumann's versus Harvard architecture. Von Neumann architecture is a traditional architecture used in most modern computers where instructions and the data are stored in some memory. Harvard architecture used in some embedded systems separates the instructions and the data memory, allowing simultaneous access the both. The choice of architecture depends on the specific requirements of system such as performance, cost, and power consumption. Micro Microarchitecture refers to the implementation of ISA in a specific CPU design. It includes the organization and the structure of a CPU such as pipeline stage, cascade hierarchy, and branch prediction machines. Brand prediction mechanisms. Different microarchitecture can have a significant impact on performance and power consumptions.